Let's solve this equation for x. So remember your steps. Are there any fractions? The answer is no. Are there any parentheses? The answer is no. So let's use the addition property of equality and let's make it so we have variable terms on one side of the equation and constants on the other side. To do that, I'll begin by subtracting 5x from both sides. So here's the left side of my equation. I'll leave a little space. Here's the right side of my equation. And now I'll subtract 5x from both sides. So I'll subtract 5x on the left side. I must do that to both sides. Now watch what happens. 8x minus 5x, that's 3x, plus 14 is equal to 5x minus 5x is 0x or 0 like I wanted, and I have 44. So I've got my variable term over here. Let's get constants on the right side. I'll subtract 14 from both sides. So here's the left side. Here's the right side. Now I'll subtract 14 on the left side, and I must do the exact same thing on the right side. And notice what happens. The left side, I have simply 3x. The right side, 44 minus 14, that is 30. And now what do I do to solve for x or get x by itself with an understood coefficient of 1? I will divide both sides by the coefficient of x. So I'll divide the left side by the coefficient of x, the right side by the coefficient of x, and I'll have x is equal to 10. I'll let you check, replace x with 10 here and here in the original equation and make sure that a true statement results. Let's solve this equation. First, I'll go ahead and remove parentheses and brackets. So by the distributive property, that's 9x plus 9 times 2 is 18 is equal to 5 bracket. Now be careful, I've got to work within the innermost set. So that's 11, I'm multiplying, minus 4 plus 2x plus 3. So what do I have? I have 9x plus 18 on the left side. Nothing can be combined, unlike terms. Why don't we go ahead and combine like terms on the right side within this set of brackets first. 11 minus 4 is 7, and 7 plus 3 is 10 plus 2x. And now let's continue. 9x plus 18 is equal to, using the distributive property, 5 times 10 is 50 plus, that's 10x. This is a linear equation, so let's move x's. I have a habit of moving x's to the left, numbers to the right, makes no difference. If you subtract 10x from both sides, 9x minus 10x, that's negative 1x or minus x plus 18 is equal to, subtracting 10x on the right, I have simply 50. Then I will subtract 18 from both sides and go ahead and write that step down if you need to. But if I subtract 18 on the left side, I have negative 1x or negative x. If I subtract 18 on the right side, I have 32. I'm not solved because I need the coefficient of x to be positive 1 or an understood 1. So on the left side, I divide by the coefficient of x, which is negative 1. And I have x then is negative 32. I'll let you check it by replacing x with negative 32, but my solution set is the set containing negative 32. How do we begin solving this equation? Remember to go through your steps. There are no fractions here. There are parentheses, so let's multiply by using the distributive property. That's 3 times y, which is 3y, minus 3 times 4 is 12, and then plus y is equal to 2 times 6 is 12, plus 2 times 2y, that's 4y. Do we have any like terms that we can combine on either side of the equation? The answer is yes. 3y and y, that's 4y minus 12 is equal to 12 plus 4y. Now let's continue by moving variable terms to one side of the equation, constants to the other, and it makes no difference what goes on what side, but I'll just move variable terms to the left side. It's just a habit for me. So I will subtract 4y from both sides. So here's the left side of my equation. I'll leave a little space. Here's the right side of my equation. And now I will subtract 4y from the left side, and I must do the same thing on the right side. Now watch what happens. 4y minus 4y, that's 0y or 0, and I have negative 12 is equal to, this subtracts out also, and I have simply 12. When all your variable terms happen to subtract out and you end up with a false statement, such as we have here, this is a false statement, that means that there is no value for y that will make this a true statement. So what is your answer? Your answer is no solution, or you can use the empty set notation. But this original equation has no solution. You might have seen it up here when we have 4y minus 12 is equal to 12 plus 4y. No matter what value, what real number I replace y by, 4 times y, then subtract 12, will never equal 4 times that same y added to 12. But if you didn't, this will work out for you. This equation has no solution.